Cory Reynolds, who is the Corporate Affairs and Communications Director of Veolia UK. Welcome. We have Robin Brundle, apologies, be clear on that, Executive Chairman of Technology Minerals PLC. We have Ken Byng, who is the Senior Manager at Car Takeback.
Morning.
And we have Dr. Gavin Harper, who is from the Faraday Institution, and you're a research fellow there at the University of Birmingham. So,
Morning. Morning.
Welcome. Thank you. We've got a number of questions for you, and then I'm sure the committee members will have supplementaries as well. So if I can open the proceedings by asking each of you to give us an overview of what's your assessment of the UK's readiness in light of the 2035 phase-out dates in terms of the required EV waste disposal facilities and indeed the UK's recycling capacity. So Cory, perhaps if you could go first.
Of course, thank you. Thank you very much. So our view on end-of-life EV batteries is that the current projections for 350,000 tonnes of material to be processed by 2040, there isn't currently enough capacity in the UK to be able to process that material. Veolia has a battery reprocessing facility at Minworth in the West Midlands where we process 5,000 tonnes of EV batteries, and that's separating out the black mass material from the batteries and the metals. We forecast that there would need to be at least 10 times the type of facilities that we run at Minworth to process stage 1 and stage 2 of battery facilities. And what we would like to see to enable that is faster and more efficient planning permissions given for these types of facilities. We would also like an extended producer responsibility type legislation for batteries for the full life of the batteries. We would also like batteries to have a waste code specific to batteries to make it easier to separate out that waste, to process that waste in the UK. I think that probably gives an overview of where our focus is. It is worth saying that batteries within general waste streams at the moment are a huge problem for the waste industry. They cause regular fires, stopping our capabilities of processing waste, and that's not just batteries, it's small electrical batteries, so scooters, toothbrushes, even as far as vapes. So we would like to see a lot more clear legislation around these issues.
Thank you. Robin.
Yes, good morning. At Technology Minerals, we are what you would know as junior miners and looking specifically for battery metals in ethical places. Processing plant in the Midlands with a permit for 22,000 tonnes of processing of any chemistry of lithium-ion battery. So what that means is everything from a vape through e-bike, through car, through train, forklift truck and so on. So we've got the wider view of the other chemistries other than just EV. From a strategic point of view, I think there's work to be done on supporting the UK strategy in the sense that a circular economy already exists, but most roads lead to China. So the black mass, for example, that we talk about here from the battery waste actually cannot yet be processed here in the UK. So by default, all of the money that we've put and from the great work into academia means that our black mass material is being shipped to, in most cases, South Korea or Japan, which is ultimately ending back in China for manufacturing of batteries to be shipped around the world. And as you may already know, China has the lion's share of the global supply of battery metals over their acquisitions during the last 20-odd years or so. And so the circle exists, but we either need to be a disruptor or create our own, and we need to be clear on that. And the UK needs to support a policy of, are we a trading nation or are we not? Because regulation at the moment states that any battery waste, so if we want these raw materials to come in to the UK and to be retained here, Currently, the legislation by government is that battery waste is classed as green. So in essence, we welcome the raw material coming in. However, when it filters down through the agencies that permit that to happen, there is difference of opinion. And so there are blockers in the system with that. So I think support through looking at the detail of that system would be beneficial to say, are we genuinely a trading nation or are we not? And once we've made that decision, we need to be very vocal about it. The second element of this is that we have a possible win-win situation with regard to raw materials. If you actually look at the legacy situation here in the UK, HMRC is currently paying just for around 400 mines in the UK that the taxpayer is picking up the annual liability for maintaining. But we're not able to do it properly. Rivers are running orange, areas of natural beauty are harmful to humans, but we're still rubber stamping a 400 million a year fee through Treasury. You may wish to ask Treasury for their view on how much they pay, not just for those mines that are focused on battery metals, but also the old coal mines, because you run into billions at that point. Those slag heaps, those tailings have got many of the raw materials that we need for the battery space, which is the relevance of my point. Sorry, I can see you grimacing. But there are many, many resources here in the UK that if only the industry could be cornerstoned by government, i.e. there's no appetite for investment in mining here in the UK, the problems and the legacy costs are challenging to tier ones. If we're going to go back to finding our own sort of resources, we have to find a way to have some form of amnesty on legacy clear-up to actually facilitate the extraction of raw material. That is critical because academia are forecasting that we will only ever, through recycling, be able to achieve a maximum of 30% of the raw materials that are required. As a result of that, by default, 70% have to be extracted. Okay? If you wish to transition as a consumer to EV products, you have to have raw materials. We cannot create these products from thin air. And so I then, so from a raw materials point of view, from a strategic point of view, from a trading nation point of view, we now have most of this capability, and the black mass is the next blocker in the system. So when you look at the black mass, the tier ones, such as the Glencores of this world, their business model to invest 400 million into a European hub and spoke scenario where it becomes viable is a sensible business case. To invest 400 million here in the UK, if you leave it to captains of industry, it is not viable, so therefore it won't happen. So companies such as ours, where we have to prove viability, are looking at bringing in this black mass capability in the very near term, but only on a small modular basis. So if we wish to have a narrative that we're a world leader, it will need cornerstoning to invite the tier ones to have super investment in the black mass treatment. Otherwise, you're back to a commercial business model. There's more to perhaps talk through, and I will thank you for your time and pass on.
Thank you, and thanks for the opportunity today. Obviously, batteries have been talked about, but the other part of this is the electric vehicles themselves. So I would say currently, in answer to the question directly, we have sufficient capacity within the industry for dismantling these vehicles, perhaps the next 2 to 3 years. But I think beyond that, once we expect the volumes of these vehicles to rise, and at the moment, they're predominantly premature end-of-life vehicles that we're seeing. So they will be, accident damaged, written off by insurance companies, or they might be vehicles which prototypes from vehicle manufacturers themselves and that sort of thing. So, and obviously I'm talking about lithium-ion battery vehicles at the moment. Nickel metal hydride batteries are a different matter. I assume everybody believes, for the purpose of this inquiry. We have been seeing those for an actual end of life for a long time. But focusing on the lithium-ion battery vehicles, I think once the volumes start to rise, the issue we've got at the moment is it's a small network, small part of the network of the UK's authorised treatment facilities who dismantle these vehicles, who are trained to dismantle these vehicles, who have the right investment in the equipment, in their premises, and in their techniques and tooling. So I think what we need to move forward for our industry, for the end-of-life vehicles themselves, is that we need growth in this area. We need more investment from the authorised treatment facilities to take account of the growing volumes that we're going to see. But I think we also need better enforcement of the existing regulations, because the end-of-life vehicle regulations, I know there's a question coming on a little later on those, but I think to have a level playing field, we need fair enforcement. When we get that helps the industry grow, that helps encourage investment and gives confidence in investment. Because where we're at is that obviously we have an electric vehicle which is very different from an internal combustion engine vehicle, if we leave hybrids aside for now. So within these vehicles, what we lose from a value chain perspective is the engine, the gearbox, the catalytic converter, which are all high value items from a conventional end-of-life vehicle. So what we need to realise is value from the replacement components, the lithium-ion batteries, the motors, the control gear and the control systems and all of that. There is a lot of work going on, as colleagues have mentioned earlier, in this area. Currently, lithium-ion batteries, I think, tend to take care of themselves if they are serviceable, because the way that the regulations are written at the moment, they can be resold on. So the more business-like, or the people who are more switched on within these authorised facility companies, treatment facility companies, they will leverage that, and they can replace the value chains by selling those on. But there are also smaller authorised treatment facilities who are not in that business really, they're not at that level. So what we really need is, as I say, a bit more certainty, a bit more enforcement from the regulations, I think, to encourage that confidence for investment. There will be other issues as well, unfortunately, for some authorised treatment facilities, because some are on very small sites. They work very hard at sweating those assets. They're very efficient and effective at what they do. But the issues are when you replace an internal combustion engine vehicle with an electric vehicle, what you have then is, they're large vehicles in themselves. If they're damaged, they need to be sited 15 metres away from any other vehicle or anything else. The batteries themselves, lithium-ion batteries, are significant sized batteries. There are requirements for safe storage of those, so there's more space needed on these sites. So there are quite a few issues with growing what we have currently. And as I say, one of the things that can help with that, I think, is better enforcement of regulation, better resources for the enforcement of the regulation, to make sure we've got level playing fields and that it's worth the investment for these companies. There is another issue at the moment as well, which we work together on as an industry with vehicle manufacturers, etc., and DEFRA, and that is the information that's currently available to the authorised treatment facilities in dismantling these vehicles. So again, under the existing end-of-life vehicle regulations, extended producer responsibility part, the manufacturers have a responsibility to make sure that the information is freely available for the authorised treatment facilities to be able to safely dismantle these vehicles, safely remove the batteries from the vehicles. So that currently, some manufacturers are very good at it and the information is excellent, very easy to follow, others less so. So again, that's something that I think we need better enforcement on in the future as far as the vehicles themselves are concerned. Batteries are being covered by experts in the room, so I shan't talk too much about those, other than to say that my personal take on it is that I agree black mass processing is a big issue for the UK at the moment, and that does need resolving, and it needs support.
Thank you. Gavin.
Hello there. I agree with Robin's assessment that one of the challenges that we've got is if we want a circular economy of electric vehicle batteries, we've only got one very small part of the circle at the moment. We haven't got all of the additional elements that are required to valorise that material and then turn it back into useful batteries. So that's a big issue. It's important that capacity is built in lockstep with the actual waste arising. So it's no good prematurely building lots of processing facilities and not having the material to service those facilities. The analyst Hans-Erik Mellon talks about this Chinese proverb, too many monks and not enough porridge. And so the challenge is at the moment in this very early stage that we may have lots of people that want to shred batteries but not sufficient waste arisings to actually make those facilities viable so that they're not mothballed. Now, the other challenge is everyone talks about black mass processing, this idea of taking a battery, shredding the battery, and then producing this sort of mixed black mass that we can then use a variety of physical separation methods to recover the active valuable material. Now, there's a challenge there. If you can imagine the analogy of if you take a battery as a layered structure, if you can imagine a Victoria sponge, and I give you that sponge and I say, can you separate the materials out cleanly? At the moment, what the recycling industry does is takes that sponge, puts it in a blender, and then we've got to work out how to recover all of the bits. Now, within the academic research that's going on at the moment, we're trying to look at the whole process flow sheet of not just that first stage of how you separate the material from the battery initially, but taking that all the way through to recovered material. And one of the challenges is if you mix everything together, your chemistries to then drag out certain things that you want have to be very selective. And so we treat recycling as this sort of end-of-pipe challenge, and we've built this capacity for shredding, but actually looking to the future, and especially looking at some of the different batteries that are coming along the line in the future, where there's less value to recover easily, what we might want to do is look at disassembly, so taking that sponge apart, recovering the materials cleanly, not just making a mixed black mass, and then the subsequent chemistries that we use to turn those materials into useful battery materials become a lot simpler. That may involve some front-end work in terms of making batteries easier to disassemble. So if we look at the whole spectrum of batteries on the market at the moment, if you look at a Tesla Model S, you can imagine that as 8,000 little Swiss rolls altogether. That's very difficult to disassemble. If you look at a Chinese BYD cell-to-pack design, that's like very, very big flat batteries that potentially could be very easy to disassemble, very easy to recover the material cleanly. So it's about having the right quantity of capacity available. It's also about having the right type of capacity available.
Thank you. Baroness Boycott wants to come in.
Oh, no, sorry, I didn't mean to interrupt you.
All right, okay.
I was just wanted to ask a question.
I thought you were finished.
Yes.
Yes,
okay.
Yes.
Can I ask, I don't quite know who answers this, something a bit more about this whole thing of extended producer responsibility. I mean, how far does this responsibility go? I mean, if you sign up to it, I mean, you started on it, Cory, and I mean, are they meant to take it right through to the recycling of the black mass that you were just talking about and getting the elements of the car, all the various elements, to the right place so that they're no longer damaging or they're in a particular state that they could be used again? What does it actually mean when you sign up in this?
So I think in an ideal world, we would like to see that there's an introduction of a take-back scheme for waste industrial lithium-ion batteries.
Take back by?
So take back as in you can take them back to where you got them from. So that would be part of the manufacturers, part of the producer of that material. So they would be responsible for that battery, for the whole life of that battery, including the recyclability of it. And I think that's one of the things that would really encourage eco-design in terms of better design for recyclability. As Gavin was just saying, being able to separate out those components very easily. It would also encourage the potential for reusability. So in EV, for example, at end-of-life vehicles, you've got a battery that might still have 50, 60, 70% of capacity, but rather than taking it apart, it could be reused for storage, it could be used for other things in a properly administered scheme. In terms of EPR measures for EV batteries, we think that it should, to answer your question, cover the whole life of the battery. So whether that goes to reuse, whether that goes to potential repair, or whether that goes to recycling.
Robin, did you want to come in on this?
Yeah, I've got 3 or 4 points, if I may, just to add what's been said. So to pick up on this point first of all, the producer responsibility, let's drill it down to a product. So, when we first had mobile phones, you could disconnect the battery from it, change your battery, send your battery somewhere to have value in a chain of some description. But today you can't. They're specifically glued into products to make them waterproof and so on. So I believe that there is challenge on producers to say, look, let's look at those, because we know we can get from a laptop, we can get the glass, we can get the plastic, we can get the circuit boards, but we can't easily get the battery. So we then have to go into a shredding scenario to do that. So that's one example of that. The other example then as well is the end-of-life batteries. This is a really fast-moving environment, and I would urge caution around this, because yesterday Warwick University declared that they feel actually that putting EV cells back into second life actually is not now the correct thing to do, because the materials in those older batteries actually, once processed, would now make 5 new batteries. And therefore, is it effective to have something that's operating at between, say, 50 and 80% of its efficiency, where those raw materials, with the way that manufacturing has improved already, could actually produce 5 new? I'm not saying they're right, I'm just saying that's the narrative. The other aspect of this is to consider the insurance voice, because they are experiencing poor quality repairs being done in the marketplace, to the point where the insurance industry, I believe, is considering do not fix. So if a car that they're responsible for, end of life, be an insurance write-off, whatever it is, and so please, I would suggest that you seek opinion from the insurance world as well, because they're finding it to be very volatile to take repaired products into the marketplace. And then there's a third piece about consumer responsibility, because we're not recycling enough effectively. So there is a piece to say, what can we do? Can these producers have to pay money into compliance schemes? Could a compliance scheme fund a 4th bin collection for local councils, for example, that specifically focus on your electric toothbrush, your vapes, your whatever, so that actually we capture more of this material? Because our forecast this year is that there's 83,000 tonnes of material, and we will, in the next few months, process around 8,300 tonnes. And we could actually get all of that material just from the waste vapes. They're all going to landfill. So look at the legislation as well. There is a very fast win here. At the moment, we as the UK perceive batteries to the point we perceive batteries in the whole. So if you take lead-acid handheld device batteries, they represent 4% of the UK's pot of batteries this year, but in evidence for the producer to say they've recycled, they represent 78% of the evidence, which fundamentally means that most lithium ion is either being stored, incinerated, landfilled, or exported. So we actually don't have a process, and by actually splitting those batteries by type, you could actually get the raw materials from lithium with a very fast win, with an acceleration of the battery regulation 2009.
Would extended producer responsibility become a government responsibility to say that everybody has to sign up?
It needs to be driven by government to form the legislation to make it a responsibility. And from what I'm reading, I believe that in our trade discussions with Europe and the US on a minerals strategy, there is a common ground amongst nations that producer responsibility is the first part of the chain, along with assisting consumers to be more responsible.
Thank you very much.
EPR has been around for quite some time, and a lot of the countries on the continent have, particularly France, has extended producer responsibilities. Just on your point, Robin, we have taken evidence we have asked for evidence and have received it from insurance companies.
Fantastic.
I've got 2 committee members who want to come in on this. Can I encourage witnesses, given there's a lot of interest, to be as brief as they can? Ken, do you want to respond to that point quickly before I move on?
Yes, very quickly.
Right, thank you.
Just to sort of clarify, extended producer responsibility already exists under the waste battery and accumulators regulations in this country. So, but a lot of manufacturers take this seriously, going back to what I said earlier. Currently, it's a minimum of 50% of a battery needs to be recycled, and that does extend to the producer. How it's enforced is a different matter, and how much of it happens in reality is a different matter, but the regulation is there currently. That is being reviewed. The EU have already put their proposals forward for their review, and we will follow soon. So.
It's clearly an issue we will pick up with DEFRA. Can I first go to Baroness Young and then Lord Lucas?
My question really could be raised under any of the questions that we're talking about, but it might as well come sooner rather than later. This is an incredibly complicated process, and we've got umpteen government departments involved. We've got the Department for Business and Trade, the Office for Zero Emissions, the Department for Energy Security and Net Zero, DEFRA and stroke the Environment Agency, local authorities. I mean, so it goes on. Department for Transport because of the producers. I mean, is there somewhere that this is all being masterminded as yet?
Welcome to our world.
I mean, is there any mechanism for masterminding it?
I think Gavin, then Robin.
Oh, yeah, we've put together a policy commission chaired by Sir John Beddington, Securing Technology Critical Metals for Britain. And in there, one of our recommendations was that because of the cross-department nature of lots of these challenges around critical materials, there was some need for coordination. So we've now got the Critical Minerals Intelligence Centre. And I think, you know, that sort of thing is a really good platform because we're looking at batteries here, but there's other challenges around other technology critical metals used in electric vehicles, such as rare earth magnets, which have got their own recycling challenges, etc. And I think looking at these specific issues relevant to critical materials under that organisation is probably...
And is the Beddington Group a government group or...?
No, that was convened by the University of Birmingham. Sir John was previously a government chief scientific advisor. We brought together industry, academia...
So there isn't actually a government
experts.
Coordination process. You've had to invent your own.
It was our suggestion in that, and on the basis of that, the Critical Materials Intelligence Centre was set up and a whole range of other initiatives.
Thank you.
Yes, I would say pretty exhausting lobbying, really, is where it's been in history. I personally would recommend, and apologies, I don't know what is the correct mechanism, but some form of effective select committee type that is ongoing, because you can see this is such a fast-moving environment here. You know, forward roll 12 months, and you're going to be faced with a whole different set of circumstance that if you legislate now, you're going to be behind the curve still. So this almost really needs something that is live, that has some additional agility. This is what other nations that are getting ahead of us have done. They've said, we understand the risk of these materials, let's control harm to humans. Beyond that, let's open up legislation. With our EU money, let's welcome in and create competitive tension to bring in, you know, the tier ones and the serious players into our country. We're behind that curve. And we had the metals convention here, mining and metals, last week in London. And the narrative there was very much that actually the upward pressure on supply of copper in 3 years' time will be a big problem. We have an amazing history of mining for copper. We should not only be looking at being a disruptor and playing catch-up here, but do we also have the ability to look forwards and say, if we were to cornerstone mining here in the UK to make it more appealing to the investment sector, could we actually get ahead of the curve? And so, you know, it does need commerce and politicians and, you know, a rounded approach to this, but it does need energy delivered from the top. Back to you for that one.
Thank you. Lord Lucas.
I like Dr. Harper's cake analogy, but actually taking black mass, smelting it, getting a mixed metal, which is relatively simple chemistry to separate, and ash with lots of lithium in it, again, simple. This is back to my A-level chemistry. It is not, and it doesn't matter what the design of the battery is. It all goes through the same process. Isn't that much easier than trying to design a machine that can deal with 96 different varieties of cake?
So there's easy, and then there's what would look good in terms of recycling recovery efficiency rates. So there's a whole spectrum of different recycling technologies. You've got pyrometallurgy, as you say, smelting everything down. You've got hydrometallurgy, and then you've got this concept in the future of direct recycling. Now there's two things to bear in mind here. On the one is the value of the materials contained within the battery in their raw form. So if you think of it like a game of snakes and ladders, you start off with your raw material here, up here's your finished battery. Every roll of the dice is a processing step that takes you up. Now, pyrometallurgy takes you a long way back down the board. You're taking that material back to a very basic form where you've got to invest lots of energy to then take it back up to a finished battery. Hydrometallurgy takes you slightly less far down the board, but direct recycling enables you to keep not only the material itself, but also the value that's embodied in all of those processing steps to turn those raw materials into finished materials. Now, if you've got batteries that are very nickel rich or very cobalt rich, you can put them into a pyrometallurgical process and you can recover the value out of the nickel and the cobalt. But if you look to the future, we're seeing more and more people pivot towards lithium iron phosphate batteries, LFP batteries, or LMFP batteries look very promising. Now, these batteries haven't got a lot of intrinsic value in the raw materials. People in industry talk about them as rust and fertiliser batteries. So you haven't got the value there in terms of nickel and cobalt to recover via these more traditional processes. And so the only way that you could really recover the value in a meaningful way is to keep that cathode material in as near as possible to its finished form and perhaps rejuvenate that material. Now, if you're shredding it up and you're mixing it together, it makes it very difficult to do that and recover any meaningful value. And speaking to recyclers around the world, I've heard a figure saying that some of them say our processes will tolerate 5% of that LFP material through their process without affecting their profitability too much. Well, if we start seeing the market share of LFP increase significantly, which I believe it will because it's a cheap material and it's not reliant on critical materials in the same way as some of these cobalt and nickel rich formulations, it's the lithium that's the main challenge there. Then we've got a challenge as a recycling industry if we've built lots of plants to shred batteries that can't then produce a waste that can easily be valorised.
I think Robin and Cory wanted to come in, if you can, briefly, because we've got a number of other questions that we need to get on to.
Of course, I just wanted to make a point following Gavin's discussion there on lithium-ion batteries and the waste code and the health and safety aspect of this. So lithium-ion batteries are assigned a non-hazardous EWC code at the moment, the same as other non-hazardous batteries and accumulators that don't contain lead, cadmium or mercury. We strongly believe that lithium-ion batteries should have their own hazardous EWC codes, because that would help not just in the reporting and the management of the risks around the management of lithium-ion batteries, but it would also ensure that recycling is undertaken by responsible operators, given the hazardous chemicals that we're discussing in the batteries, and, as previously mentioned, the serious risk of fires that we all experience on a far too regular basis.
And just to come on the chemistry, as if I may, you're quite right. First of all, the automotive industry through history levels a chemistry for commercial reasons and volume to bring pricing down. We haven't yet seen the auto industry level yet. So to Gavin's point is, when they level, it would be great to try and persuade them to make the cake so that we've got a common technology across the globe for the automotive as far as is commercially possible. The second is that the reason the black mass currently goes out to Asia is that they have a process that enables them to split the black mass and recover around 80% of the lithium. Previously 60, now 80. In Europe and the US, they're washing away the lithium at the start of the process, leaving only the remaining 3 salts. Warwick University here have developed a process that we're working with and with a car company, where we can extract the lithium from our black mass to a 99.8% quality, enabling enough to go back to be cradle-to-cradle material so it can go back into a battery, because the challenge is not cradle-to-grave, it's cradle-to-cradle, which is what we're trying to deliver. So this work is here in the UK. We've got it. We've invested in the academia. They're brilliant. We've just got to upscale the TRL level, and it's on its way.
Thank you. Did you want to come in, Peter?
Yes. We have been told that 85% or 84% of the cars sold in the UK are manufactured abroad. Therefore, how does this affect things? If we lay down rules about how cars are produced and so on, to what extent will British rules determine how BMW or China or Kia in Korea make their batteries and make their cars? To the extent that we do recycle them, will we be recycling foreign batteries to redirect the materials to Nissan and Jaguar and Toyota here, or will we then have to export the materials to the countries which made the cars originally, from which the batteries have come, which we've reprocessed? And finally, slightly different. From what I gathered from what you said, there's no point really in recycling unless we've got some primary lithium manufacturing capacity here. Is that correct?
I'll gladly come in. Sorry, did you point?
I did. I went to Gavin, then Robin, if that's okay.
Pardon? Sorry.
Yes, so I think the automotive industry is going to be a major consumer of lithium-ion batteries, the major consumer of lithium-ion batteries, but I think it's important not to neglect the fact that lithium-ion batteries will find other applications in our energy transition. So if you think about the support for grid and enabling greater penetration of renewable assets into the grid, there's going to be opportunities to build lithium-ion batteries for energy storage, and so I think there's reasons why we should be making lithium-ion batteries in the UK that extend beyond just automotive applications. So I think there's a possibility to develop that lithium-ion battery industry in the UK independently of the automotive industry, but I do think we need to think about what vehicles are we manufacturing in the UK. The types of vehicles will in part determine the types of batteries that are required for them. So for example, if you're building luxury vehicles where people want very, very long ranges because that's that segment of consumer, they're going to be quite high cobalt and nickel batteries still, because you need them to deliver that volumetric and gravimetric energy density. If you've got lithium iron phosphate material, that's going into your more budget and standard cars. So it's a case of matching the recovered material to the type of vehicle that it's going into and aligning that end-of-life process, but also that manufacturing process.
Robin, you wanted to come in?
Thank you. The automotive space is self-governing this, in the sense that there's legislation in place currently under challenge in the EU that you have to have, by a certain time frame, 55% of the car has to be manufactured locally. And by that, in our case, they're talking about Europe and the UK. So by default, there has to be minerals enough in the system to be able to achieve that, because in this modern powertrain situation, the battery is more than half the weight of the car. So already it's a challenge if there are not raw materials enough to build the batteries at the plants here in the UK. So that's where the pressure point is. Where are the raw materials coming from? Predominantly China. And China's got the circle, yeah? And this is what we're trying to break. And the US are saying as well, unless you've got this local content, 55% local content, you cannot sell your products in the USA. So there is global automotive control, and I think the industry may also do a throwback to the 70s and 80s, where Japan suddenly brought in their Kaizen production processes, and we're going to storm the world. Europe then said, actually, we will only give you 10% market share, up to you how you divvy it out between the Japanese car companies. We may end up going back down that model, because the Chinese really have got a really fast start in the auto space. So all of those discussions, I'm sure, are going on within the political arena.
Sorry, just very briefly, just to explain as well, the extended producer responsibility also includes importers. So if you've got cars and batteries that are manufactured abroad, both sets of regulations still mean that the importer who brings the vehicle in, or the manufacturer who brings the vehicle in, they still bear the same responsibility. So that they still have to make sure that that vehicle and that battery is properly treated and recycled at its end of life.
Thank you. Baroness Bray.
Thank you. Looking to the consumer and all this, it sounds pretty grim news for them, really. And I'm wondering, in your opinion, how much of the sort of news you're bringing us today impacts on their decisions whether or not to buy one of these vehicles?
I'll answer that one. This is a really interesting one. So, currently, at a vehicle's end of life, the market tends to take care of it. The extended producer responsibility regulations are in place to make sure that even if if scrap prices drop through the floor, then that vehicle would still be able to be taken back free of charge from the consumer for responsible recycling. That is the same with batteries. It's exactly the same with batteries, really. And currently, obviously, with lithium-ion batteries, there is a cost implication to them being recycled anyway. As I said earlier, some of them can be resold if they're fit for resale. So that's that part of it. My personal view is that I'm not sure a lot of consumers think that far ahead, really, necessarily, when they're buying a vehicle. I could be wrong there, but that's my perception. And I think that there is an issue there at the moment with education of the general public, with consumers, in my personal opinion, because I think that there are some parts of the media that are trying, as we all know, to discredit electric vehicles, trying to discredit lithium-ion batteries. They're trying to give the impression that they're not recyclable and they're being stockpiled here, there and everywhere. Clearly this is not true. We know this. They can all be dealt with. They can all be recycled. We know we've got the issues with black mass at the end of the day. But my personal view is that we need a joint education campaign, with industry, government, all of these different parts of the equation, really, to educate the public so that they understand that actually that vehicle can be recycled, and actually it's very important that battery can be recycled, and if it is, it can then go towards manufacturing a new battery in the UK. That's my view on it. So if that helps.
Yes, thank you. The two key blockers for consumers right now are range anxiety and cost. And if you look at the cost at the current time, we're seeing the prices of electric vehicles actually tumbling in their thousands periodically. And this is as the new technologies are setting to level, as the batteries are becoming more voluminous, volume drives cost. And so when we get to next year, I believe that the European car manufacturers will be far more competitive in range anxiety. And suddenly there will be products in the market next year, I believe, that will be able to be compared with fossil fuels on their distance of travel whilst using your wipers and your heater. And also the charging mechanisms for the new types of batteries, some are claiming in under 15 minutes. Well, suddenly that becomes a much more compelling consumer proposition. And if the prices continue to tumble because of competition, which is a natural process, then frankly we start to align with more volume of the products coming through. And I don't think we should dismiss hybrid of hydrogen fuel cells, but please do also bear in mind that they carry lithium-ion batteries to transition the energy from the hydrogen through a battery, through motors onto the vehicle. So there's still lithium batteries involved, but purely much less in density and volume. So I think they're the two key blockers. The minute that you can say to a family, you can do 500 miles on a range of a battery, and it will charge in under 15 minutes, we're in a different world. That doesn't help the early adopters.
You want to say something, Cory?
Yes, I think the current waste battery regulations that we've heard about, producers and consumers can take back the battery at the end of life. However, it's, as Ken alluded to, it's not widely communicated or publicised by battery producers and car manufacturers, and that has to change. This might be due to the fact that electric vehicle batteries, there's a cost associated in recycling. And that may be one of the barriers that, again, we need to look at and how we bring that down. I think that also pushes across to what we're seeing in terms of batteries, second-hand batteries being purchased on the internet, being used in an unregulated way, being used, in vehicle conversion or DIY energy storage projects, and reuse is important, but the industry needs better regulation, and the rules around recycling batteries need to be much better enforced with proper waste codes, with properly regulated EPR.
I mean, what are we talking about in terms of the lifetime of a vehicle? Because, I mean, you're saying you don't think people are necessarily that bothered when they buy a new car about how long it's likely to serve them. But actually, I would say that actually I think a lot of people do actually think about whether or not this is a car they're going to get able to drive the next 15 years sort of thing. And I think at the moment you're saying, yes, they can, but only with a large cost halfway through when they're going to have the battery looked at. And
yeah, I mean, if I could answer that, I think it's fair to say that when electric vehicles, particularly battery electric vehicles, first came onto the market in the UK and the EU, etc., the general sort of thinking was that the batteries would be good for about 8 years. They've far outlasted that. They've proven to be very, very resilient, and that they last a lot longer, particularly in the UK, because we don't have the extremes of temperature and that sort of thing, and not the sort of length of travel in distances that you might have in other markets and that. But yeah, I think if anything, it's that sort of that side of it. People realise that actually an electric vehicle will last them just as long as a conventional vehicle. Personally, but as I said earlier, the issue is some parts of the media, that some of the articles that are written are very, very misleading, and they're wrong. So that will have a bit of an impact. But something else is that the European Union they've already put their proposal forward on the waste battery and accumulators regulations rewrite. So a lot of the holes that are there at the moment, particularly with things like Second Life and all the sorts of things that we've talked about, they're hoping to address those with the rewrite of these regulations. The UK, we've just started really the review of our regulations. Current thinking is that we will align, hopefully, with the EU regulations. There are probably some areas where we could actually improve them, but certainly that process is ongoing. So the hope is that a lot of these issues will be addressed, and certainly DEFRA are working with industry in the consultation process to try and cover a lot of those areas, which should hopefully address some of those issues.
Just a final question. I mean, is there ever going to be, well, in the near future at least, any time soon, that the battery won't have to be sort of completely taken to bits and put back together again, and there's going to be a new type of battery where you just have to slot a few extra bits and pieces in and it's off ready to go?
They're currently in the UK, I would say that market is nascent. So in other markets, so the Netherlands in particular, and Sweden, other places like that, they are way ahead of us with all of that. Right. So there are Second Life applications which tend to take the form of they might be sort of a portable energy bank, to replace a mini generator that people might have used at one time. Some companies have got, they're manufacturing big, huge units that can be used on construction sites instead of the big old generators. So they're charged and then delivered to site, and then once they're depleted, they're collected and replaced with another one by the companies that manufacture them. They are manufactured through batteries at the end of their first life, quite often. So that is happening at the moment, and even things like home energy storage systems. But the UK, as I said, we're behind the curve. There are some companies that are doing that, but only at quite a small scale. And I've got personal experience of this, because we try and leverage that sort of Second Life use where possible. Because if you've got batteries that have failed through, if they're warranty claims, for example, so somebody's had an alarm on their vehicle, they've driven it back to the dealer's had a look and said, right, we'll just replace the battery. When the battery's off the vehicle, once we assess that battery, actually, that battery, once you strip it down and you test it and cycle it, it is actually okay for Second Life use, so it's not an end-of-life battery. So, notwithstanding all of the discussion that's gone before that Robin raised about, what the right thing to do is with the battery. Certainly, my belief is that Second Life is a viable option, but I think we need to... Part of the reason it hasn't flourished really is that the current regulations, the current waste battery and accumulators regulations don't allow for that. They don't cover it. And that's because back when they were written many years ago, it wasn't an issue. You hadn't got lithium-ion batteries really in vehicles. So again, what the EU have done is that they've tried to close that gap really and tried to put into place mechanisms so that these Second Life uses are regulated properly. If we can shadow that in the UK, then that gives the industry confidence to invest in this sort of this sort of Second Life application. The only other thing is that battery chemistries and technologies, as has been alluded to earlier, are changing all the time. So in order to have volume products for Second Life markets, you do need to have a lot of the same or a lot of very similar battery modules and that sort of thing. So, there are a lot of issues around it, but certainly it is something that is possible in the UK, and hopefully the regulation will support that, and we can see further activity in that area.
Okay, thanks.
Looking at the time, I'm going to have to close this question down because we're not going to get through everything, because I know Baroness Young wants to ask a quick... You're fine? You're sorted?
Answered. It's been
Brilliant. Okay, we'll move on, and if there's something you want to raise within another point, please do. Thank you. Lord Whitty.
Well, my question the big question has been answered, that you don't find the current regulations effective. Could you be more explicit about what needs to improve in terms of the regulations, and if the EU proposals are a move in the right direction, but are they good enough, and are they likely to be adopted by all types of cars? So the Japanese and the Koreans have similar regulations, or is it more a question of enforcement? I'm not even clear who is supposed to enforce these. When I was this Minister of Transport, we had responsibility, which we didn't exercise very well, over the quality of breakers yards. It has improved a bit since, but is it the Department of Transport? Is it one of the agencies of transport, or DEFRA? Or is it DEFRA itself? Who is actually supposed to enforce the regulations that we've got, and what are the key elements of an improvement in the regulations, and have the EU at least got something right in this respect?
Want to go first, Cory, and then we'll go down the
so
line.
I can respond on the EWC code. So that is a DEFRA matter, and we would like to see lithium-ion batteries have a specific hazardous waste code under that legislation, and for that to be enforced.
And enforced by whom?
Well, that would be the EA.
The EA.
Environmental agency.
With
DEFRA behind them.
Environmental agency.
Yeah. Okay. And I suppose a related matter is this enforced more effectively in other countries than it is here at the moment? Has it? You've talked about Sweden and the Netherlands having better quality of recyclable or reusable batteries, but is the legislation and the enforcement of the legislation better anywhere in the world than it is here?
If you don't feel able to answer, we can ask other colleagues along the list. So, Robin, would you like to
I would support exactly what's been said around DEFRA and the EA. I would caveat that in the sense that we're not throwing daggers at the EA here. They do a great job, in our opinion. They are short of resource, frankly, for a number of historical reasons that you'll be familiar with. But secondly, it's very difficult to enforce something if there is nowhere for that enforcement to go and resolve the issue. So in the case of lithium-ion batteries, until we went live with our facility, the EA had nowhere to demand that people take the batteries other than landfill, which is less than desirable. Yeah. So now we are alive, and there is now this capability in the UK. We would ask that the EA be given additional resource to actually police it. So to give you one example, material arriving at our site today was actually stored first in early 2021. So all of this pent-up demand are sitting around the UK as potential fire hazards, and it needs to move now. And it's these types of things where you cannot criticise if there's no exit. There is now an exit. I believe that the Battery Regulation 2009 is a solid, robust document, but it needs to now have teeth to deliver it and empower those agencies responsible, because there are more than one department responsible in some of these examples. But to your point, I think those battery regulations have given us, right or wrong from Brexit, have given us the freedom to exercise. So one example is that Europe classes the batteries as hazardous waste. We currently produce it, we welcome it as green waste so that we can get the raw material in, to my point of are we or are we not a trading nation. The slight problem there is that the Environmental Agency then believe it to be hazardous waste, and when it comes to permitting, that is the responsibility of the Environmental Agency. Yeah. And right now, you can have all this work done by academia, but they themselves take 18 months to get a permit from the EA, not through fault of the people, but just lack of resource, in our opinion.
Who's they?
The Environmental Agency.
You said they take...
The EA are responsible for the permitting, so the personnel within the EA are currently taking 18 months to even vary a permit. So if you can have all the investment in academia, but if you wish to then transition, even if academia wishes to transition up the technology readiness level, they have to wait to get the same permit that commerce does. And so there is this, we've had plants sitting idle for nearly 2 years waiting for permitting. Yeah, so this capability has been sitting in the wings. There's no individual people responsible, but the organisation is under-resourced. And so we would urge you, so my direct answer is I would say that our legislation is agile, it seems to be on the money, it seems to be live, so people are changing it as the circumstance change, but we need to resource those that are going to accelerate the ability to do something with it. Otherwise, we're always going to be followers.
Right. I mean, I know things have improved significantly, but traditionally the industry has not been, shall we say, the most obviously regulated industry. If there are a lack of resources in the agency which is primarily responsible, is there a case for having a different agency or a different system of enforcement?
I would support that, and as just a piece of thinking, I struggle as a businessman to understand we fund academia to learn how to do it properly. We then actually put an agency in place to regulate them, but the agency has to learn all of the stuff that the academia has already been through. So why would we not engage academia and fund academia to support the permitting and licensing and the knowledge transfer, a much greater knowledge transfer, because they've done all the early stage work. With our knowledge transfer with Birmingham and Warwick, for example, the sharing of knowledge has accelerated both academia and commerce. Fantastic. Why would that not be allowed to be influencing the Environmental Agency to help them, for example? Thank you.
And I should declare an interest, as should the Noble Lord Whitty, in his case as a board member of the Environment Agency in the dim and distant past, and in my case as Chief Executive of the Environment Agency. And I mean, is it not true to say that most academic institutions would run a mile from the prospect of becoming a regulator for a system that is very dispersed amongst a whole load of operators, that is very fast moving? It's simply not their job. Regulators should regulate, not academics regulate. I mean, Dr. Harper, where would you stand?
I think even applying for the process of the permitting as an institution has been, a significant challenge and taken up bandwidth and overhead and time that people would have rather spent elsewhere, so I tend to agree with that view. Could I pick up on a couple of the previous points as well that were made briefly? Okay. Of course, there are licensed routes for vehicle disposal, but then there are also people that unscrupulously dispose of vehicles, and that then falls burden to the local authority. And one of my grave concerns is that if we should get to a point at which the cost of disposal disposal of vehicles to consumers becomes too high. What you've got to remember is that the consumer that owns a vehicle at the end of its life is probably very different from the consumer that bought the vehicle in the first place, and it cascades down the uses. And so if we were to see an uptick in unlicensed vehicle disposal, burnt out cars by the side of roads, that's going to be a burden that disproportionately falls to local authorities to deal with, and that's going to impact their budget lines. One thing I would say, you were talking about swapping batteries out, so the Chinese firm Neo, they have batteries that are sort of hot swappable. They can be taken in and out of the vehicle.
That's in Israel, actually, funny enough, a few years ago.
Yeah, Project Better Place, there was talk about that as well. So, that's a different model, one that hasn't really taken root in the UK, but the fact that you can get the batteries in and out of the vehicles, that potentially will impact their recyclability and is something that should be explored further. Talking about battery life and longevity, the Darn Group in Canada have talked about this idea of million-mile batteries. Now, how many million-mile cars do you see? And the potential is that battery life could actually outlast vehicles as traditionally conceived. Your seats and the interior will wear out before the battery. And so there's this question about how to valorise and extract the best use out of the battery, because there's the materials on the one hand, but then there's also the energy that you've input into manufacturing that battery at the first place. Now, the challenge with second life applications, taking that battery out and putting it into a different application, is the fact that, the product is regulated as a battery for a car, and it's certified and type approved as a battery in a car. It isn't then type approved as a battery in a house or a factory or whatever. So there's this concept of vehicle to grid, whereby you can plug in a car to the grid, have bi-directional power transfer, and actually what might be good is if we wear the batteries out while they're in the car and get the best use out of that battery and then recycle it, rather than looking at taking a product that's designed for one application and then transplanting it into another.
Interesting. Is you want to comment on this issue briefly?
Yes, just briefly, just quickly to answer Gavin. Hopefully we won't get to that point again where cars are abandoned because of the ELV regulations, the end-of-life vehicle regulations. But also to answer another question, my personal experience is, because we do work in other markets, not just the UK, as car take back, the way that the end-of-life vehicle is the end-of-life vehicle directive is a directive in the EU, and as I'm sure you know. And that is then transcribed into regulations in the different member states, and that happened in the UK when we were a member state. What they're now doing with the new review is it's going to be a regulation, so it's not going to be a directive, because there were a lot of differences with the way that different markets, different countries implemented the directive. Just a couple of other answer a couple of other questions very briefly. It does get confusing between different departments who have to enforce different parts of the regulations. And if you take, for example, the end-of-life vehicle regulations again, you have DEFRA who are responsible for making sure that vehicle manufacturers and authorised treatment facilities report targets and recycle the vehicles to the right percentages. But then you have the Environment Agency who are responsible for going around and visiting all of the authorised treatment facilities, and for policing that and making sure they're doing what they should be doing, and for closing down illegal sites. So there is a bit of a gap there, I guess, in that. And also just to sort of echo what Robin said, although there are a couple of other facilities in the UK that can process battery splat mass. But I do know that there are definitely issues with permitting at the moment. And again, as Robin said, both with DEFRA and the EEA, any issues, in my opinion, are not down necessarily to the regulations. Although the waste battery and accumulators regulations do need changing, they do need updating. But I do think that the issue is enforcement, and I do think that's a resource issue with both sets of the regulations.
Thank you. Baroness Jones.
Moving on then to the issue about how much of the battery can be recycled, and we've already begun to explore all of this, and I've learned an enormous amount so far in the first hour about black mass and how it's shredded and so on. I'd like to explore this a little bit more. Your Victoria Sandwich example was very helpful, but how much? What is it in a battery that wears out in other words, is it the critical minerals in it that are kind of burning out in some way? So if you start off with a battery, sorry, I know nothing about batteries, so bear with me. If you start off with a battery, why is it? What's in it that stops it going on forever and doing 1,000,000 miles or whatever? In other words, is it the rare minerals that eventually we will lose if a battery runs long enough? That's my first question.
Okay, so to try and simplify this as far as possible, you're taking an anode material and a cathode material, which is a mixture of different metals, and it's the structure of those metals that allows the lithium ions to intercalate and de-intercalate across the membrane. So you've got a range of different degradation mechanisms that take place within that battery. It's not that the materials are being consumed, it's that the structure that you've created initially starts to degrade over time. And so the idea of direct recycling is that perhaps you could take those materials in whatever structure they're left in and rejuvenate that structure, rather than taking those metals which are still there but then having to take them back to a raw material to then reintegrate them into a new fresh structure.
Okay, that's good. That's helpful. So that's my first question. So then, you at Faraday are doing research on this, where your challenge is that you're going to make batteries 95, the content of batteries 95% recyclable, which seems like a reasonable challenge. So how far down that road are you now? I mean, we've learnt about the progress of the science, but update us on where you've got to and where you think you'll be in the next 12 months.
Okay, so the challenge is everyone can recycle the sort of high value bits of the battery, the nickel and the cobalt. That's where the value is. But we want to look at how can you actually valorise and recycle the whole battery. So there's lots of different challenges there, in terms of recovering anode material and being able to get value from that. The stuff in the battery that isn't particularly valuable, things like the separator materials, the plastics. At the moment, if you put them into a pyrometallurgical process, people that talk about we're recycling, high percentage figures of the battery, well, actually, a lot of the plastics, for example, are being burnt to produce energy in that process. So, it's dubious how well you could say that's actually been recycled. So, for a true circular economy, we want to keep those materials in as high a value state as possible to be able to properly recycle them, not just recover energy. So I think we've got elements of the process where we've got sort of key technologies around being able to delaminate material cleanly to then be able to put it into recycling processes. We've got work on using AI and robotics to be able to disassemble batteries to cleanly separate those materials rather than just shredding them up and mixing them all together. So there's this suite of different sort of keystone technologies, and our challenge now is to be able to scale those up, demonstrate them at higher technology readiness levels to actually show industry this is a viable alternative solution to shredding. So we've got some of this work going on at Tyseley Energy Park in Birmingham, where the Birmingham Energy Institute have got this massive demonstrator site for a whole range of different energy technologies. We've got work there where we've got robotic disassembly cells that are able to take a battery, take it apart and actually disassemble that battery to then lead to high value materials recovery. So it's on a journey to try and scale up that technology readiness level and get that closer to industry. So when the real volumes start coming through, because at the moment we're dealing with fairly trifling volumes of batteries coming through the system, but we anticipate for this 2035 target there'll be much larger volumes down the line. And what you've got to imagine is that as those volumes of waste start to scale, so do the volumes of the chemical reagents that are needed to do all of that end-of-life processing and hydrometallurgy. So if you've got inefficient processes that are, requiring a lot of chemical input to be able to extract not a lot of material, you start sort of scaling that by the volume of waste, those volumes could become, absolutely colossal. So the more efficiently we can do that, the more efficient we can make the chemistries. Hopefully when those volumes start to come, we can deal with that in as efficient way as possible, both in terms of energy and materials input.
So it sounds like you're quite a long way towards your 95% target. So you might hit that before the 2035 deadline, from what you're saying.
Yeah, I think certainly if you look at groups around the world, so we've got the ReLib project at the University of Birmingham, which is the UK's largest project on recycling and reuse. In the US, we work with colleagues at Argonne National Labs on the Resell project, which is a similar counterpart there. There's work going on at CSIRO in Australia. So internationally, there's a really well integrated community that's looking at all of these challenges around battery recycling. We're all working on different parts of the puzzle. As a scientific community, we collaborate really well, so everyone's working on a different bit, and I certainly think by the time that target comes there will be new solutions to battery recycling which differ significantly from industry current practice. And I think there's always going to be a case for shredding some batteries, for vehicles that have been involved in a crash. You don't want to be disassembling that with a robot. For small batteries that are used in consumer electronic devices, there's not going to be any value in disassembling those small batteries. But for larger batteries used in energy storage, used in large electric vehicles, I think we're going to see a lot of evolution in recycling technologies and perhaps in battery design to enable recycling. And I think by 2035 the landscape may look significantly different to how it does at the moment, and that will be aided by a lot of technologies that are in the lab at universities around the world at the moment.
That's good. Okay, can you one more quick?
Do they have to be... Before you carry on, I think that Robin and Cory briefly wanted to come in and just respond to that particular point.
Thank you. Yes, on your recycling, I'd like to give you some comfort. So the process that we have in the UK has been designed in the UK, built in the UK, run by a UK company, and academia are describing it as world leading. So we have an edge on recycling. The second thing to say to you is that 100% of every lithium-ion battery that goes into the process is separated and collected. So by the end of December, at the moment we're high 99% of reuse in some form. Arguably some may have to go to energy, but by the end of this quarter we believe that we will be absolutely zero to landfill. So we are doing something, even with the liquid in them called electrolyte, we're able to recover that as well. So be reassured that the recycling, UK recycling, is in good health in that sense. Thank you.
And just to add to both of the points around battery design, so at the moment the aluminium casings around batteries which are welded together and some of the foam around the batteries make it very difficult to dismantle and to reuse or recycle those, and that design for recyclability is really important going forward to organisations like us, because we need the manufacturers to think about how those batteries are going to be dismantled, how they're going to be recycled, and how those components can be reused in the future.
Okay, so my quick supplementary is, are they always going to be a fire risk? Are they always going to be flammable? Or is your part of your design going to make sure that, because we've heard that they can't be stored near to each other and there's, all those issues, could we have fireproof batteries in the future?
Different types of cathode chemistry have got different risks in terms of safety. I was mentioning earlier about the lithium iron phosphate batteries that are considered, particularly cost effective. They're also very intrinsically safe in terms of their energy density compared to the high cobalt and high nickel batteries, and that's one of the reasons that we might see the prevalence of this particular LFP chemistry, which is starting to be used on vehicles with lower range, but currently there's lots of improvement work happening because it uses less critical materials. Now that chemistry presents a real challenge to the recycling industry to recover any value at the end of life, because it's lithium, rust and fertiliser. There's not lots of value in there unless that material can be kept in its sort of finished form and rejuvenated.
Thank you, Robin.
Thank you. Yes, I would also say, in my very simplistic way, is that the industry appears to be moving towards something called solid state. What does that mean? It means at the moment we have liquid in the lithium-ion batteries, okay? And that liquid is where fundamentally the explosion element of the battery actually is at its worst, yeah? So solid state, in my simplistic view, is just literally take that liquid away and create the chemistry environment without the liquid, which then actually takes away elements of fire triangle and explosion chemistries. And so we welcome the move actually to a solid state, because it's going to be so much safer, we believe, for us all, but we can still recycle those batteries, and they genuinely will have value to the value in the circular cradle-to-cradle economy.
Thank you very much.
Thank you. Good question. Bruce.
Thank you very much. It's a fascinating morning. It's very complicated. It's changing very fast. What I'm thinking, like Baroness Bray, about the consumers who are looking on and saying, what are we going to do here? You've got the early adopters, who you say may be the losers, not the winners in some of the cases. But the people who are not yet ready to adopt, they've got all these considerations. So when a car comes, first of all, most people buy second-hand cars. So they're going to come along and say, I'm buying a car, it's 6 years old, it's 7 years old, what am I buying? What's the state of the battery? What happens to the, if the battery's half the car, and I buy a car, a year later there's a battery problem. So how's the industry going to cope with that, give assurances? Is there also a danger that you'll say, we'll scrap the car, even though this car might have, in its own condition, several years of useful life, as long as it's got several years of useful battery? I know you're saying the battery is ultimately going to last a lot longer, but at the moment, in the current state of the market, it seems to me consumers inevitably going to be wary, because they know with a fossil fuel car that you wait until either the mileage is high, or the gearbox is going to fail, or the engine is going to fail, and that's usually terminal, end of life, end of car. So they're not sure with an electric car what is the same comparator, which also feeds into all this business. If you can actually reboot a battery, that sort of becomes a sort of a point at which trade-in, you can say, look, we can sell you this car, it is 7 years old, the battery's rebooted, in normal sense it's good for another few years. But at the moment it all seems to be a bit up in the air, and consumers are likely to be rather resistant because they really do not know how to calculate the value of buying a car, what they should pay for it, what they should get out of it. So, I mean, how do you address all of that?
If I can answer that one, if that's okay. Well, as much as I can anyway. I think ultimately that is a question for the manufacturers, and I know that manufacturers have been here, but certainly there is work going on at the moment with various different manufacturers and manufacturers that manufacture in the UK who are looking at the possibility of can batteries be repaired, and that comes back to a question that was asked earlier. And if they can be repaired, how do you recertify them to go back into a vehicle? So again, because everything is moving so quickly with the different battery chemistries and the technology in the vehicles, if you've got an electric vehicle that is 10 years old, the likelihood is that battery won't be manufactured anymore, certainly not in the same format that it was in that vehicle originally. So there's potentially a market there for these remanufactured batteries, but again, the waste battery and accumulators regulations as they're written don't cover for any of that really. So again, that's something that is being looked at, and something that needs to be looked at really. So it's possible, exactly as you say, that people may be able to then buy used vehicles that have had a reconditioned battery in them, and that sort of thing. And different manufacturers give different warranties with the batteries and with the vehicles and that. So some are quite sort of, aware of this, I think, and aware of consumer reluctance. But also, again, as part of the waste battery and accumulators regulations review that's happened in the EU and their proposals, there are things like battery passports coming along, and what that means is that then, for the life of a battery, whoever comes into contact with it, whether they be a vehicle manufacturer, main dealer, or an independent dealer, or even at the end of life, potentially an authorised treatment facility, they should have some way of interrogating that vehicle, of interrogating that battery, to find out what the life of that battery has involved, and what the condition of that battery is at that point. We're not there yet. Obviously, as was mentioned earlier, with these regulations and that, even once they come into being, they're going to affect vehicles that are manufactured down the line. We have a lot that are on the road already. So it's an interesting one. You're absolutely right. It's definitely a challenge, but there are measures being taken to try and address those concerns, and they have to, because otherwise consumers will, they wouldn't be interested, even though they're being pushed in that direction anyway.
Thank you. The genesis of the problem for the auto space is that when they did the calculations, the average UK driver drives 82 miles per day. and the average battery life is about 250 miles. And the industry thought that that would be enough, and they underestimated the comparison with fossil fuel. So what has that done? It means that those that are genuinely doing the average of 82 miles per day will become the natural users of the used products as they fall in price. So I think the natural flow of the ownership profile will continue, personally. But what will be a pressure point is that we know already that the replacement cost of a battery pack is well north of £10,000 on average, well north, yeah? And so will those people be able to get insurance? Mm-hmm. Or will that car actually come prematurely to end of life because of a lack of insurance? Because if an insurer has got a car valued at £8,000 that's going to cost north of £10,000 to be responsible for a battery, let's say, it's just not likely to happen. And so I think that will be the pressure point, is that when the battery should fail, even if it's prematurely, the car then will be prematurely finished. But the natural circle of life of the car ownership profile, I genuinely believe there'll be a limited market to cities perhaps where the 82 miles is relevant. And then, as I said, from next year, there's products coming on the market with 400, 500, 600 mile range.
Just to sort of add to Robin's comments, really, there is a lot of work going on at the moment between the insurance industry and the end-of-life vehicle industry, looking at these green parts. So, it's win-win for the insurance companies with conventional vehicles, because obviously it brings the cost down. As long as those parts can be certified as suitable, and equal to replacement original manufactured parts, then it makes sense for it. It certainly makes sense for the industry. There is work going on, and it's being looked at with regard to lithium-ion batteries as well. So it's possible that work might extend, and in that case, that might resolve this issue with the insurance companies. But you're absolutely right, Robin, that there are a lot of insurance companies out there that are getting very nervous about electric vehicles and insuring electric vehicles, which is an issue that needs to be overcome. They are going to be around, aren't they? So
that's an important point.
Lord Whitty, you wanted to come in.
It's a question about the structure of the world automotive industry. My understanding has always been that in the Western world, at least, is dominated by huge international companies who manufacture all over the place. And they surely, even though the battery may be 50% of the value of the final electric car, they must specify what kind of battery they're going to incorporate. So if you've got Ford and Tesla and, I don't know, 3 or 4 of the other companies around the table to specify what sort of battery we're going to have, surely we could get all these improvements put it. A lot of responsibility lies on the final assemblers here, as well as government regulation. But surely the power in the land is the automotive producers.
They've got to compete, haven't they?
I think, one of the things that's really positive is that we've seen lots of sort of aggregation and agglomeration in the automotive industry. So you see, Volkswagen, Seat, Skoda all part of one big group. You see Stellantis part of another big group. And obviously with electric vehicles posing such a big challenge for that industry to transition, enormous R&D costs, etc., they have clustered around a smaller number of platforms and designs as groups of manufacturers. So I think, to some degree that process is happening already. I think part of the challenge is that manufacturers have got enormous, sunk costs invested in this first generation of electric vehicles, and so they just want to try and extract some value out of that R&D work that's been done. So I think there's lots of reluctance at the moment around, doing evolution for design for recycle, etc. But I think what's going to really drive that is probably competitive pressures from China and the Chinese vehicle manufacturers, who are really that far ahead in terms of their thinking, we think, on some of the design elements of electric vehicles, especially around this sort of cell-to-pack concept, etc. One of the things, just picking up from Ken's point, and I think is something that's worth flagging up and being mindful of, is that not all batteries, when the car is scrapped at the end of life, are going to be recycled. Lots of them will be sold into secondary markets to be reused, remanufactured, etc. We're seeing a really big sort of informal trade of electric vehicle parts. You look at the online auction sites and you can buy electric vehicle modules, batteries, packs, and a lot of people are doing some incredibly ingenious things with these, building home power storage systems, taking old classic cars where the engines have gone and converting them to become electric vehicles. And I think, there's a degree to which this reuse of second-hand vehicle parts is something that's always gone on. There's always been a kit car industry, etc. That's a great thing. But I think we need to think carefully about how safety is managed within the context of those regulations. And obviously, people building their own cars has gone on for a long time. We manage that safety appropriately within current regulatory frameworks. But I just think it's worth giving some thought to that, about how the context changes with electric vehicles going forwards.
Just in case anyone's thinking of doing a spin-off of the repair shop, it needs to be regulated properly. Thank you. Robin, I think you wanted
to support Lord Whitty's thinking, on Radio 4, the boss man of Stellantis this morning was declaring that they themselves now feel that they're able to take the commercial fight to compete with the Chinese products. So, to your point, the settling down of costs is very much happening around us in the way in which the automotive companies achieve it.
And the government are bunging quite a lot of money to manufacture in Bridgewater. Are the specifications for that going to be the right ones?
Exactly, yeah.
And did you want to come in first and then anyone respond to the bridge?
Yes. Just briefly, just in answer to Robin's point, it's absolutely right that there is this sort of thriving industry at the moment whereby these batteries, the big concern is the lithium-ion batteries, obviously, which are being sold on online auction platforms. They're being sold over the counter to members of the general public. I could tell you some horror stories, but I won't. Now, currently, that is not against the law with the way that the waste battery and accumulators regulations are written. So what we hope, again, is that and I keep talking about it, I know, but with the review of the waste battery and accumulators regulations, we can build some sort of mechanism into that actually regulates that rather than the free-for-all it is at the moment.
Anyone else wants to come in on the Bridgewater point? No?
Well, sorry, I do, but in that, could you tell us particularly, Dr. Sorry, I can't read. Anyway, once you've built a battery plant making one type of battery, can it be repurposed to make one of these solid-state batteries, for example? Or are we putting all our money in something which may turn out to be a lollipop? I don't know. The other thing is just a purely technical point. You said 82 miles a day, that's 30,000 miles a year. I thought the average car use was 11,000 miles a year.
To answer that one first, that's a stat that the industry used to say that the average journey is no longer than 82 in any one go. Not that we all do it, but in other words, why did they choose 250 as a range? It was because their indicators were nobody really went any further than 82, and they underestimated the fossil fuel comparison.
That was a minor point compared with
And to comment on your solid state. So, if you imagine an automotive production line, it has a chassis going along with a certain body shell coming out of it today. They stop for the summer break. It comes back on the same production line with another body shell of a different size, shape and scale on it. So it's about tooling and jigging and understanding the chemistries. So I think once the facility is built, I personally, as a taxpayer, would have no hesitation to say money well invested, because it should be agile enough as a building to accommodate more than one product through the same type of evolution.
Good, thanks.
Briefly, a couple of minutes left. Yes.
So I was going to say, just picking up on the earlier comment, I think one of the challenges is around when a battery actually, speaking to colleagues at Birmingham Law School, when does a battery actually become a waste? When is it still a product? that can then be sold into a second life, and when is it classed as a waste? And I think there's a real definitional issue here that's thorny. Picking up on your point where you were talking about, investing in the factory, how much of the factory is it that can then be repurposed, I think is a question. Is it just the shed and you have to change all of the equipment inside? Because I think there's so much variety as far as lithium-ion batteries go. You think about the form factor, the actual shape of the battery. Are you making little can batteries, or are you making big flat long batteries? So these are apples and oranges in terms of the type of batteries and the way in which they're made. Then there's all of the investment in the actual chemistry that goes into the battery. So certainly there will be investment in things that could be reused if things change, but there will also be things that potentially, would be outmoded. And there's also that sort of technological lock-in that if you invest in a certain set of stuff and you've got a certain set of tools and a certain set of skills, your natural inclination is just to keep using the same thing and doing the same thing. And so I think it's really important that we have some scrutiny at this point to say, actually, are we going to be making things that are going to then be able to be reused at the end of life, or are we making things that are going to create a little bit of a challenge down the line?
And that's where the extended producer responsibility can make a big difference.
For sure, and picking up on your point as well, and the point that you'd made about disassemblability, design for recycling. We've done lots of works. Glues and adhesives in batteries are absolutely terrible. Trying to get things unstuck is really, really difficult, and I think it's thinking through some of those processes, whether it's smart adhesives, mechanical fixings, what can we do to make batteries that can be taken apart easily at the end of life?
Yes.
I think we're out of time, Baroness. I'm sorry. I'd like to thank all four of you for your contributions today and for educating us on quite a complex issue, and doing so in a way that those of us who find this more challenging than others were able to at least follow. So thank you for that.
Well done.
We appreciate your thoughts. And with that, I close the session.
Thank you very much.
Thank you. Thank you.
The proceeding has ended. 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 The proceeding has ended.